Okay, this is quiz one. We're going to start by doing each of these by hand and then pulling out the calculator to kind of show you how that works. So negative 17 plus 8. Well, that's kind of like saying I owe somebody $17, but then I pay them $8. Well, that means my debt's going down, and now I really only owe them $9. So it's still negative because I still owe them money, but it's not as much. With number two, the biggest thing to remember here is that when we subtract a negative, it becomes a positive. So it ends up saying negative 16 plus 4, which is a very similar question to this one. If I owe somebody $16 and I give them $4, I now still owe them $12. So it's still negative, but it's negative 12. So for both of these, you can do them in your calculator as well. So you can say negative 17 plus 8 and get negative 9. And you can say negative 16 minus a negative 4, and you get negative 12. So you can do them both on the calculator, or you can do them in your head. I suggest thinking them both ways. Try them and then check them on the calculator as well, just to make sure that you have the right answer. Number three is a little bit different because with number three, I owe somebody $48 and I add another debt of $6. That means I've really increased my debt. So now I owe somebody $54. And I can do that one by saying negative 48 plus negative 6. And I get negative 54. So the next one kind of gets more into the algebra. Anytime you see anything with the parentheses, you want to deal with the parentheses first. So I'm going to start by just kind of copying the rest of this. So I say 31 plus 7 times 5 minus 1.8. And then I have to say, okay, well, what's 47 minus 22? So I can always pull out my calculator and say, okay, 47 minus 22, and I get 25. So because they're right next to each other, it's going to become times 25. Because right now that 1.8 is on the outside, so it's being multiplied. So then I want to look through, thinking of the order of operations. I did the parentheses. There's no exponents, but I'm going to multiply and divide and before I add and subtract. So now I have 31 plus 7 times 5. Well, 7 times 5 is 35 minus 1.8 times 25. Well, 1.8 times 25 is a little bit longer multiplication, which is 45. So then I really have 31 plus 35. Well, if I add those together, I get 66. And then I take away 45, and I get 21. Now, the other way to do this, and if you do it by hand, that's great, but I suggest double checking it, is to actually type this in so it looks just like it does on the screen. So you're going to say 31 plus 7 times 5 minus 1.8, and then I had that parentheses right away, 47 minus 22, and the other parentheses. So basically, it should look just like it does in the question, and you get 21. So doing the work out is great. I love to see that, but please do double check and actually type it in just to make sure that you're in the right track. Okay, then same thing with fractions. We can do the work. You can also do them on the calculator. It's good to do both ways. Adding and subtracting have something in common, and that is the fact that you need to have the same number on the bottom, that common denominator. So to do that, I think, what do both 9 and 3 go into? Well, they both go into 9. And so my new bottom number is just going to be 9. Well, this is already in ninths, so I can just copy that one because it's 4 ninths. To get from 3 to 9, I multiply by 3, so I'm going to do the same thing to the top because whatever you do to the bottom, you have to do the same thing to the top. So then I'm going to say, okay, well, 2 times 3, and that's going to be 6. And then as I add things, if I have 9 on the bottom, 4 plus 6 is 10. Well, that's the same thing as 1 and 1/9. Now on your fractions over here, Same idea applies. I want the same number to be on the bottom. Well, 4 doesn't go into 14, so I can't use 14, but 4 does go into 28, and so does 14. So my new number, my new denominator, is going to be 28. Well, 14 times 2 gives me 28, so negative 3 times 2 is negative 6. So really what I'm doing is saying whatever I had to multiply the bottom number by, I multiply the top number by the same thing. So 4 times 7 is 28. So 1 times 7 is 7. Then once you have that, the bottom number stays the same. So now I've got negative 6 minus 7. Well, it's going down further. So you get negative 6 and you're going down 7 more. So really you're at negative 13. And both of these you can check on the calculator by saying, we're just going to use our fraction key. So I'm going to say 4/9. And then get out of that fraction, say plus 2/3. And I get 1 1/9. Then for this one, I'd say negative 3. And make sure you use the negative sign, not the subtraction sign. And then it's 14 on the bottom. And get out of that and say minus 1/4. And I get negative 13 over 28, which is what we had for that one. So yes, you can just type them in your calculator, but I want to make sure that we at least kind of cover how to do them by hand. So this one, fractions that when you multiply them are actually, I think, a little easier. So you have negative 6/11 times negative 2/5. I'm just copying it because I think it looks a little funny here. If I could reduce anything in the diagonal, I would. In this case, I really can't. So I'm just going to multiply straight across. I'll say 11 times 5 is 55. Negative 6 times negative 2. Well, 6 times 2 is 12. And a negative times a negative ends up being positive. For the division one, the key thing is you turn it into a multiplication question by flipping that second question or second fraction upside down. And it has to be that second fraction. It can't be the first one. And I can't reduce anything. Like there's 10 and 2. I can't reduce until after I flip. And now at this point, I can't actually reduce anything. But I multiply across and get negative 20 and 21. And once again, I can do these in the calculator. I think you can kind of see how to do that. I'll do number 8 for you. Pretty much you hit that fraction sign, negative 10 over 3 divided by the next fraction, which is 7 over 2. And you get negative 20 over 21. And really, once you get the hang of typing in the fractions, which I think you all have now, it makes it a lot easier. Okay, these get a little trickier. Keyword of equals times is equal. So those are kind of some words that you have to kind of know. So 32% of 150, I would write down 32% of, which is times 150. Then I would just pull up my calculator and actually type in 32% times 150. And I get 48. So the answer for that one's 48. Now once I have the answer, stop and ask yourself, does it make sense? So 150, we're thinking about a third of 150. Well, a third of 150 is 50, which this is really close. So that's about perfect. And it's a little bit less because we're not quite at a third. If I ended up with a huge number, I would know I was wrong because the answer wouldn't make sense. So always stop with these questions and just think logically, what do you think you'll get? Okay, so number 10, 78 is equal. What percent, so I'm just using X because I don't know the percent, of, so my times 50. So I really have my letter that I'm trying to find, and I've got a 50 here. I want to get rid of the 50 because I want X to be by itself. So I'm going to divide both sides by 50. And so I have 78 divided by 50. And I get 1.56. and that equals X percent. Well, it's not really a percent yet. I want to change it because it's a decimal. I want to change it into a percent. So I just move my decimal over 2 places and get 156%. Now, logically, 78 is what percent of 50? Well, it has to be more than 100% because 78 is bigger than 50. So my answer does make sense. It's about 1.5 of 50, so it's about 150% because it's the whole 50 plus another half or so. So kind of just always stop and say, does my answer make logical sense? Because if not, then you know you've got a problem. Number 11, I like because it's a straight up calculator question. You just type in the square root of 5. Make sure to get out of that square root, hit times, and then the square root of 25. So your answer would be 11.18. They don't tell me what to round to, so I usually go 2 places. If you said 11.2, that would also be fine. If you said 11.180, that's fine. The key thing is whatever you choose to round to, make sure you round correctly. So you wouldn't want to say 11.19 because that wouldn't be rounded correctly. So your options would be 11.18, 11.2, 11.180. Typically, you want to have a couple places in the decimals, but there's no right answer as far as rounding. This next one, we're simplifying. So really, I'm taking this second set away from this first set. So I have 8x and 3. I'm taking away a 6x, and I'm taking away a negative 5. So if I say minus a negative 5, that really gets to turned into an addition question. So it becomes plus 5. So really, when you have that subtraction sign, all the signs inside switch. So instead of having positive 6x, I have negative 6x. Instead of saying subtract 5, I'm adding 5 because I'm basically taking away a positive. And then when I take away a negative, it becomes a positive. So it looks like this. The idea is this becomes negative 6x. This becomes plus 5. So now I'm going to look at my things that are the same. I'm combining the things that are like terms. So I'm going to combine my x's and then combine my numbers. So 8x minus 6x is going to be 2x. 3 plus 5 is going to be 8. So I have 2x plus 8. I can't go any further. I'm only asked to simplify. I'm not asked to solve because I can't solve. I have no idea what x is at this point. But I know that this is simpler than that. Now I'm actually being asked to solve something. So let me go ahead and copy this down here. The goal is to get x by itself. I always start with the thing that's kind of connected loosely. I don't start with the number that's attached. So if it says add 41, to get rid of that or to undo that, I'm going to subtract 41. I get 4x here. Then if I say 13 minus 41, you could do it by hand or you could pull out your calculator. So you can use your calculator for these questions and say 13 minus 41 and I get negative 28. So I still need to know what x is. I know I have 4 times x, so I'm going to go one step further and divide both sides by 4. That gives me x on this side, and then 28 divided by 4 is 7, and because it's just one negative, the answer is negative. I can check this. I can say, okay, well 4 times x plus 41 should be 13. So I could actually go to my calculator and say 4 times negative 7 plus 41, and I get 13. So I know I'm right. I just put that in place of x to double check it. With this one, I have those parentheses again. And I always know I want to get rid of the parentheses first. So I'm going to say, let's go ahead and multiply what's in the outside by everything on the inside. So 4 times x, I'm going to write that 4x. 4 times negative 7 is negative 28. Then the same thing for the next one. Negative 2 times x is negative 2x. Negative 2 times positive 5 is negative 10. And then I copy that equals negative 16. So in this first step, I got rid of the parentheses by multiplying what's on the outside by everything on the inside. So 4 times x is 4x. 4 times negative 7 is negative 28. So now I need to combine the things that are the same, the like terms. So I've got my x's here. So if I have 4x, I go down 2x. Well, 4 minus 2 is just 2. So I have 2 x's. Then I have negative 28 and negative 10. Well, I'm kind of combining those. I get negative 38. If you're stuck on that, you could always say negative 28 plus negative 10. Because I'm adding those together, and I get negative 38. So you can kind of check it that way. And that's all equal to negative 16. So now I'm still trying to get x by itself. I'm going to get rid of the adding or subtracting first. So I'm going to go ahead and add 38, because it's the opposite, to both sides. That gives me 2x. And let's say I just hate fractions. I could do negative 16 plus 38. And I get 22. Then last step, because they're being multiplied, I'm going to divide it. You can ignore this. It was a little bump. So that gives me x is equal to 11. Now, if you want to do that checking part, you could always type in 4. And then wherever it says x, I'm going to put 11. So I can say 11 minus 7 minus 2, 11 plus 5. So all I'm doing is typing it in, but wherever it says x, I'm saying x is 11. Now, if I hit enter, I should get negative 16. And that's how you know you have the right answer. So you can always kind of check it that way. Okay, the key thing is whenever you have a proportion, you always multiply the diagonal that has both numbers. Actually, that's really hard to see. Let me just grab my highlighter. So I look at this and say, okay, this one has both my numbers. So I'm going to multiply that. So I say 3 times 96. And then I'm going to divide by the side that only has the one number. So divided by 8, and I get 36. Oops, 36 there. Which makes sense because if I have 36 over 96, if I have 36 over 96 and I hit enter, it's going to reduce it down to 3/8. So they're the same thing. So I can kind of check it that way too. So this one, find the diagonal that has both numbers. So 150 and 15. So 150 times 15. I hit enter and then I divide by that 4. I divide by the extra number. And I get 562.5. And I can check it by saying, okay, if I want to see if that's right, I can say 562.5 over 150. And I get 3.75. Now, that's not 15 over 4 because 15 over 4 is not a proper fraction either. If I say 15 divided by 4, or 15 over 4, I get 3 3/4. Well, that's the same thing, 3.75 and 3.75. Or I could just say, if I wanted to, 15 divided by 4, and that gives me 3.75, and 562.5 divided by 150, and that gives me 3.75. So there's different ways to check it, but basically you want them to be equal. They want them to be the same decimal number or the same reduced fraction. This one works a little bit better to check because 3/8 is a simplified fraction. 15 over 4 isn't a simplified fraction, and that's why the calculator is going to decimals. Okay, this one is the one that you got to skip, so we can kind of ignore that. So if you're reviewing, I want to make sure we pointed that out. We didn't cover that in this class, so you can ignore that. Okay, so the number 18. We have a 276-mile trip. And it takes 12 gallons of gasoline. And then how many miles could you go with 17 gallons? It's a proportion question again. Remember, the gallons could be either on the top or the bottom, but they have to be the same. I can't have 1 gallon on the top and 1 gallon on the bottom. But once I do this, I now have my diagonal with two numbers. So I can say 276 times 17. Hit enter and then divide by whatever number is left. In this case, it's 12. And I get 391. Let me change back to my pen. So 391 miles. If I wanted to check that, I could always say 276 divided by 12. Oh, that's 23. And then 391 divided by 17. And I should get 23 as well. That way I know that they are proportionate. I didn't multiply the wrong thing. Okay, so this is the question when you talk about graphing that I suggested making a table. No, your grade is not based on making the table, but it helps me plot things. I typically start with -1, 0, 1. What I might do on the final exam, if there's a question like this, I may write the table in for you so that you can fill that in. I think that would be helpful. So I will add that if this question's on the final exam before I make copies. I will make a table for you. And I'll try to pick numbers that work nicely that you can actually graph without changing things. So it might be 0, 1, 2, depending on what that would be, so that you don't run off the paper. And so I'll kind of give you that table. I think that would be helpful. So then for this one, I'd say, okay, well, -1 times 4 is -4. -4 plus 1 is -3. So all I'm doing is putting this x in place. It's kind of like an if then. If x is -1, then y is -3. If x is 0, well, 4 times 0 is 0. 0 plus 1 is 1. So if x is 0, y is 1. If x is 1, 4 times 1 is 4, plus 1 is 5. And so I would say, okay, so this is my x, and this is the x here, this is my y. So x is -1 down 3. When x is 0, so I don't go left or right, I go up 1. When x is 1, I go up 5. So 1, 2, 3, 4, 5. So in this case, those are good points to pick because it actually fits on here nice and neat. On the test, if those points don't fit as nice and neatly, then I will just write some different points in so that you can graph it easily like this. But when you graph it, remember you're saying x is your left or your right. Negative is left, positive is right. Y is your up or down. Down is negative, and up is positive. So you're going to have your points, you'll fill the table in, and then make those points on there. And then the last question on the quiz, the cost of renting a sedan for one day is basically 30 cents a mile plus $35. So how many miles could you drive for $69.50? Well, there's two ways of doing this question. I can say, okay, 69.5 equals 0.3 m plus 35. I can put it into the equation. If I put it into the equation, I'm going to start by subtracting that 35. So it ends up being 0.3 m on this side, and then 69.5 minus 35, so 34.5. Now I want to actually get m by itself, so I'm going to divide both sides by 0.3. So I have 34.5, that's already there, divided by 0.3, and I get 115. Now, a lot of you will look at me and say, I don't like this part. I don't get how you're doing that. But I just know, hey, if I have $69.50 to spend, I'm going to take my $69.50. I'm going to take away that $35, that one-time fee. And then I'm just going to divide it by the 30 cents a mile to see how many miles I can go. You're doing exactly the same thing. You're just not writing the work down. It's exactly what we're doing. And you end up with the same answer because if you notice, you're subtracting and then you're dividing, just like we did. Okay, so then the next question, if you plan to take a 60-mile round trip, should you use a $50 flat rate or the mileage rate? Well, let's see how much it costs to do the mileage rate for 60 miles. So I'm going to say 0.3 times the 60 miles, and then I have to add my 35. So on my calculator, I would just type in 0.3 times 60, add in my 35, and I get $53. So the mileage rate's $53. So I would say a flat rate because you save $3. Not a huge difference, but I mean, it's amazing how that can add up over time. So the flat rate, once you're saving money, you're probably better off doing that.